Welcome, ladies and gentlemen, to your MN39 notes, where we're going to talk about the areas of triangles, parallelograms, trapezoids, and kites. This is section 11.1 and point 2 in your textbook. I'm going to try to keep it pretty straightforward, where we're going to just give a basic area formula. It says area formula for all parallelograms, which includes some names you're familiar with: the rhombus, rectangle, and square. Is going to be simply area equals base times height. So again, the area formula for all parallelograms, including the rhombus, of course, because we know rhombus, rectangles, and squares are parallelograms, but for all parallelograms, you just take the base times the height. And folks, I'm not under the impression you've never done the area, obviously, a parallelogram. So the formulas your teachers in the past have taught you, if they work for you, by all means, please use them. I'm just going to give you formulas to kind of keep it simple. We're going to use that base times height idea every single time. Just again to keep it straight in your mind. So the area formula for all triangles is the same idea where it's base times height. See, so this is what I'm saying. I'm going to keep using that base times height idea. But if we just do base times height, then we're talking about a parallelogram, which is clearly not a triangle. So that's why we divide it in half. So again, the area formula for a triangle is base times height divided by 2. And I have a feeling you were taught to do 1/2 times base times height, which is the same thing. So whichever works the best for you. Area formula for all trapezoids. And again, I am not delusional. I understand that you've already found the trapezoid in previous math classes. But again, just to kind of keep it with our trend here, when you're dealing with parallelograms, it's base times height. Well, trapezoid is the same thing, but the problem is we have two bases. You see how you have this base B down here and you have this base A up here. So we need to find the average base and multiply it by the height. So what does that mean? Well, that means that you're going to have to average your bases. So you're going to go, in this case, if you go off to the left, B, that base, plus A, which is your other base, divided by 2. So there's your average right there, times the height. Now, I have a feeling that many of you have used a formula that looks more like this. Area equals 1/2 times the height, B1 plus B2, or again, using the B plus A over there, we could just go B plus A, and I think I'm going to do that just to keep consistent with my picture. So B plus A. So we're adding our bases together, multiplying it by height, and then multiplying it by 1/2. So either of these formulas do the same thing. If you look at them, if you pull out the 1/2 from the original parentheses here on the far left, and bring the height in front of the parenthesis, you're getting the same exact formula. It's just written a little bit differently. And this is the one, though, that I don't know if you've ever seen, and I want to make sure that you put a star by it. The area formula for all kites is nothing to do with the bases. So this is the one that does not deal with the bases, but we deal with the diagonals instead. So let's call this right here diagonal sub 1. So this is like the first diagonal. And then this diagonal right here is your second diagonal. And the reason that's important is because the formula is diagonal 1 times diagonal 2 divided by 2. And, you know, really, if you look at this kite, when you break it up with your diagonals, you have 4 triangles. 2 of them are congruent, and the other 2 are congruent. Or you can look at it as 2 separate triangles. You can look at it as this is one triangle with the diagonal as your base. Diagonal 1 is your base, and half of diagonal 2 is your height. So if you look at this formula, it's diagonal 1 times half of diagonal 2 if you want to look at it that way. So it's not miraculous, and if you actually forget this formula, which sometimes I do, I break it up and find the area of triangles, because that one I never forget, base times height divided by 2. I do want to mention again, just like all of them, you could put the 1/2 in front. So 1/2 times diagonal 1 times diagonal 2 works as well. Same thing, just looks a little different. Now, here's something to keep in mind, and this is definitely something people don't always recognize. The statement down here says, any quadrilateral whose diagonals meet at a right angle can use the kite's formula to find the area. So if you think about what we learned in the last chapter, the kite was one of 3 shapes, specific shapes that where the diagonals meet at a 90-degree angle. The other one, of course, is that golden child, which is the square. So here's what's interesting. If you know the length of the 2 diagonals of the square and nothing else, you can use this formula to find the area. The other one, and I'm sure if I gave you just a moment to think about it, you would say, hopefully, that it is the rhombus. So we have 3 shapes that can use that formula, d1 times d2 divided by 2. That's the square, rhombus, and the kite. So it kind of depends on what information they're giving you to determine which formula to use. Okay, so kind of recapping here, let's take a step back. Okay, so again, all parallelograms, and remember parallelograms also include rhombus, rectangle, and square, have the area of base times height. The triangle, which is very similar, is base times height, but you can't just do base times height because that would be a parallelogram. So that's why you divide it in half. I always think about a triangle as being half of a parallelogram. The area formula for a trapezoid is again the same thing, base times height, but because you have 2 bases, you have to average those bases. And the interesting one, which is the kite, has an area formula that deals with the diagonals. And again, if you forget that, you can also find the area of the right triangles or the 2 congruent triangles within the kite. Again, don't forget square and rhombus have perpendicular diagonals as well, so you can use the kite formula for that, and that is an easy one to forget. Okay, example 1 of 2 examples here. The base of a triangle is twice its height. The area of the triangle is 36 inches square. Find the base and the height. You know, just to keep this simple, I'm going to actually create a right triangle. The reason I'm doing that is because I know that this is the height and this is the base of that triangle, just to, you know, keep it straightforward. We also know that the area of a triangle is base times height divided by 2. And now, so this is information before I really get into the guts of the problem. Now I'm going to look at this problem again. It says the base of a triangle is twice the height. So this statement is really important because base of a triangle, the base is b, is equals twice its height, means 2 times the height. So the base of the triangle is actually twice the length of the height. And this is the way we can represent that. Now the area, I'm going to put the area of the triangle, again, is equals 36 inches squared. So now what we're going to do is we're going to fill in everything we know into our general area formula. So like we know the area of a triangle, of this triangle anyway, is 36, coming from over here. The base of the triangle is actually equal to 2h, so I'm going to substitute that in for the base. Actually, look at what I did. I put a b there instead of a h. Let me try that again. 2 times h. And the height is just the height. We have no idea what that is. And we can't replace it with anything. We have to remember to divide by 2 here. And we can do a couple different things here at this point. I'm going to first simplify this numerator over here on the right side. So I have 36 equals 2 times h is 2h squared. So h times h is h squared. Now 2h plus h is 3h, but 2h times h is 2h squared over 2. And I do want to point out that if, obviously we can just divide out the 2's here on the right-hand side, but if that's not as nice like this problem, you can put that 36 over 1 and just do a cross multiplication of that portion to get rid of the fractions. but I'm going to take advantage of the fact that 2h squared over 2 is just h squared because those 2's divide out. You take the square root of both sides. In h, in this case, only makes sense for 6. So the square root of 36 is 6. And we, right here, have our height. Now the base is a different story. The base, because it asks for both of them, find the base and the height up here. So the height is 6 inches. I better make sure don't forget my units. And my base is going to be 2 times that height, so it'll be 12 inches. So the answer to this problem is the base is 12 inches, the height is 6 inches. Now the problem down here, it says find the area of the trapezoid with coordinate points of A, B, C, and D is given. And you're going to need to graph those, and I'm going to actually pause the video so you can do that. Okay, here's my trapezoid all written out here, and it says find the area of this trapezoid. Now, in order to find the area, we have to average the bases, so base 1 plus base 2 divided by 2, and then I need to multiply that by the height. So again, base times height. So the base 1, I'm going to count here. I have 1, 2, 3, 4, 5, 6, 7. This length is 7. Up here it's 1, 2, 3, 4. And my height is this right here, the height. So I have 1, 2, 3, 4, 5. So that is 5. So now we just simply kind of plug and chug. But you notice you can't get away with it without graphing it. And I know some of you would love to not graph it. So 7 plus 4 divided by 2. So the bases are 7 and the other one is 4. So we have to average those. And then we need to multiply that by the height of 5. So let's see, 7, we have 11 divided by 2 times 5, which gives me an area of 27.5. And since this is area and we don't have a units, I'm just going to go U for units squared. And we need to make sure we're talking here about area, which of course is counting the number of square units within the shape, and that's 27.5. Just a reminder, folks, if you want to literally find a good approximation of the area, you could literally count each one of these squares in this graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. You can literally count and figure out how many squares, which is the whole point of what area is. Okay, thank you for tuning in. We'll take any questions tomorrow you have. Adios.